Okay, so I decided to make a video over a section 7.6 for you all, just because of all the snow days. It's been kind of complicated and crazy. So this is going to be your homework on Friday after the test. I know it's crazy to think that you'll have homework over the weekend, but it's not that hard, and I think you guys will do just fine. So make sure you take notes over this because I will be checking it in on Monday. Section 7.6 is called the rational zero theorem. And our first definition for this section, and only definition, is the rational root theorem. And the rational root theorem states a polynomial p of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus dot 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 a sub n x plus a naught. It's just a polynomial with integral coefficients. Then it has p over q, a rational root, in simplest terms. P is a factor of a sub naught, and q is a factor of a sub n. So we're going to go ahead and jump right into some examples of this. Our first example is, all I want you to do is list the possible rational roots. And we'll go through this. It won't be too hard. So example. List all possible rational roots. So we have 2x cubed minus 11x squared plus 12x plus 9. So what it's telling us, the definition is saying that we can take our constant term, p, so we can say 9 equals p, and then we can take our first leading coefficient, and we can call this q. So 2 equals q. Now, remember our factoring game? This will come in handy. So we're going to list all the factors of 9, and including plus and minuses. So this is going to be plus or minus 1, plus or minus 3, or plus or minus 9. Then for q, 2 is prime, so there's only 2 factors for q. And that's going to be plus or minus 1 and plus or minus 2. Now our definition tells us to take all the possible rational roots. I'm going to label it RR for rational roots. It's going to be P divided by Q. So all of those are going to be 1 divided by 1 plus or minus. It's going to be plus or minus 1. Plus or minus 3 divided by 1 is 3. Plus or minus 9 divided by plus or minus 1 is plus or minus 9. Then you have to go through and divide 1 by 2, 3 by 2, and 9 by 2. Don't forget the plus or minuses. So now we have listed all of our possible rational roots for this polynomial. And possible rational roots means when this equation equals 0. So that's what we're looking for. Okay. So our next example, I want you to we're going to find all the possible rational roots, and then we're going to take it and find the factors of that based on our rational roots that we find. So our example here is x squared minus 5x plus 6. So our first step is what? To find P's and Q's. So our P is what? 6. 6 equals P. So what are our factors of 6? We have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Then we have to find the possible factors of our leading coefficient, which in this case it's 1, and that equals Q. So our factors of 1 are 1 in itself. Okay, so then to find P over Q, our possible rational roots, we have P divided by Q, and we have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. From here, we want to find our factors. Now these are all the possible zeros that we could have, but we don't know. We have to go through each single one, the plus or minuses, and plug them back into our original polynomial. So we're going to test a few points here. We're going to test P of 1. And we want to make sure this equals 0, because if it equals 0, then it's going to be a root. So P of 1 is going to be 1 squared minus 5 times 1 plus 6 equals 2, which does not equal 1. So 1 is not a factor of this equation here. We're going to try 2. Minus 10 plus 6, oh look at this, we get 0. Yay! So we know that P of 2 is a factor because it equals 0. And to find the rest of the zeros, we're going to actually use synthetic division and substitution to find the rest of them. You can go through each and every single one of those possible roots and do it that way, but I find it easier to use synthetic substitution. So we're going to take 2, put it in our box. In our original polynomial, we had 1 as our coefficient, negative 5, and 6. So we're doing synthetic division, and you all should know how to do that. So now we get our depressed polynomial. So that's going to be x minus 3. And then we have x minus 2 as a factor as well. So here's our factorization. So if we distribute back through, we're going to get back to our original polynomial. But for here, I want you to actually state what your zeros are. So we're going to have x equals 2 and x equals 3 is our zeros. So these are our rational roots for this problem. Okay, we're going to go through a longer example, and then I have one for you to try on your own, and I will be checking that in on Monday. So for our last example, we're going to find all the roots. We're going to use the same process that we have before. So our p's, we need to find factors of our p's, which is 6. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And we need to find the factors of our q, which is 2. And that's going to be plus or minus 1, plus or minus 2. I'm going to list all our possible rational roots down here because I'm going to need more board space later. So we're going to find p's divided by q's. And that's going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Then we have to do 1 divided by 2. So plus or minus 1/2, plus or minus 2 divided by 2 is 1. We already have that listed, okay? So we don't have to list it again. Then we have 3 divided by 2, which is plus or minus 3/2. Then we have 6 divided by 2, which is 3, which we already have it. So here are all possible rational roots. So from there, what we learned before is that we have to plug in each value to get 0 for our original equation. So here, we're going to plug in p of 1, and that's going to give us -6. Yes, I want you to show this. P of 2 equals -12. P of 3, what do you think, P of 3? We're going to get 0. So we're going to use P of 3 for our synthetic division. So 3 is going in the box. And then we have 2, -3, -11, and 6. Our synthetic division. Zero. Okay, so now we get our depressed polynomial. And our depressed polynomial in this is going to be 2x squared plus 3x minus 2. So we already know one root. Our one root is x equals 3. Okay, so then from here, we have several different methods of finding this here. We could use the quadratic formula to find the rest of the roots, but I'm going to show you how to go back and do the rational root theorem again with using that. So, I'm going to leave our possible rational roots because we need these to figure out the rest of that. We're going to use these to help us find those. So now we have to take our depressed polynomial and put in our original rational roots here. So we're going to try p of 1, p of 2. We've already done p of 3, so I'm not going to do that one again. I'm going to keep going down our list, p of 1/2. So we get 3, 12, forgot 6. I'm going to do 6 too. 6 and p of 1/2. 6 we get 88, and 1/2 we get 0. So we use 1/2 again for synthetic division. Two, 3, 2, -2. That should be a negative, not a positive. Okay? So then again we have another depressed polynomial. So 2x minus 4. So part of our answer, we already know that 1/2 is a root as well. So x equals 1/2. So now we have this last depressed polynomial here. We can set this one equal to 0 and solve for x, and that'll give us our final root. So and we're going to get x equals 2. Now remember what we did the other day when we said, oh, we're going to get as many roots as our leading degree, our exponent. So we have 3. Look at here. We have 3 possible roots. They just happen to all be rational. That's not always going to be the case. And actually, for our last example, which I want you to do on your own, and it will be checked on Monday, and we'll go over it if there's any questions, but I really want you to try it. Okay? Is x cubed minus 3x squared plus 4x minus 12. From our previous example, when I said we could use the quadratic formula instead of doing the rational root theorem again, in that case, I want you to show that all the possible rational roots do not equal 0. Okay? And then that's when you say, oh, then they must not be rational. So then you have to default to the quadratic formula. So try this. Watch out for those possible rational roots, none of them equal 0 after you get the depressed polynomial. Okay? So, and then for homework, page 381, numbers 12 through 24 even.